Okay, we are almost done with chapter 10. We only have one remaining task to do. That is to calculate the risk set when the data are incomplete. So when we have complete data, calculating risk set is actually a very easy job. But for incomplete data, things are slightly more complicated. So first, let's review the definition. So again, y's. So those y's are distinct values of the original observations, and each one occurs wi or wj times in the sample. That means when I sum up from 1 to n, I will get small n. That is the total number of observations. Now we are interested in Rj. So Rj is the number of individuals in the sample exposed to the possibility of death at time Yj. Meaning we will need to exclude those who already passed away, right? Because they are already out. They will not die at time Yj. They died sometime ahead. So we will only include those who are still alive, right, by the previous time, and we also need to include or we need to add those who are new to this particular period, and exclude those who are right censored. Okay, so that is a quick idea to update Rj. We begin with the previous risk set. So we begin with the previous risk set. So we begin with the previous risk set, Rj minus 1, okay? And then we minus Wj minus 1. This is the number of deaths, right, at Yj minus 1. Right, so we have to exclude those who died at Yj minus 1, because now we are interested at Yj, so we have to exclude those passed away. And then, because for complete data, that's everything, right? This is what we deal with for complete data. Now, because we have incomplete data, what we need to take care of, so first we need to add those who are new. Well, they are not exactly new, but they entered the study from the surgeries that were done before, right? Before the beginning, they were not included for the previous ones because they already survived more than that. So a quick idea is, let's assume this. Let's assume Yj minus 1 is 4, Yj is 6. Okay, so the previous level is 4 weeks. The next level would be 6 weeks. So now let's consider here. 0 is the beginning of my study. So now let's consider a patient who received his surgery 5 weeks prior to the start of this study, 5 weeks ahead. So he is not exposed to the death time at 4, right? Because he received the surgery 5 weeks ahead. And even at the very beginning, he already survived the 5 weeks. So this patient, he's not exposed to the death at 4, but he is exposed to the death at 6, because once we start, he already lived 5 weeks, but there is a chance that he would die in the next week. So he is exposed to the possibility of death at time Yj. So we have to include those, right? So we need to add those. This person is not included in R4. That's because there's no chance, there's no possibility for him to die within 4 weeks, right? That's very clear. But it's possible that he would die within 6 weeks. So he's exposed to the possibility of death at time 6. but not 4. So we need to add those back. Okay. So actually be careful with the inequality sign. Okay. So even this is 4, it's not, even this is 4, exactly 4. This patient is not included for the previous one because he already survived for 4 weeks, right? Even he dies in the next second is more than 4, right? So you have to include for the next level instead of, for the previous level, because it's already beyond 4, right? It's already greater than 4, right? There's no way to be equal to 4 anymore. Okay, that is just the take for the time. We do not take equality for the next one, because if this is -6, if this is -6, then again this patient is not exposed to the possibility of dying at 6, because we think for this is already beyond 6. He already lived 6 weeks. Since by the time of our study he still alive, then the death time will be greater than 6, will never be equal to 6. That's our handling of time. That's why it's greater than or equal to the previous level, but strictly less than the current level we are trying to study. Right? Currently, we're trying to study the number of patients who might die at week 6. Okay, 6 weeks. Then we need to minus the observations with this. Those are the survival numbers. They survive more than more than this number, but we don't know. We simply have no information for the next level, so they are already out. So let's say here's 12. So someone not this. This is a bad example. Let's move a little further. So let's say 9. We need to greater than it, so we need at least 8. So let's put 8. Okay. For this particular patient, we know is U is 4, right? It's greater than the YJ, but is less than 6. Okay. Okay, for this particular patient, we know he survived at least 4 weeks, but we don't know exactly the value. And we have to take him out because we don't know. We simply don't know. We know he survived 4 weeks, but we have no idea whether this patient could live for 6 weeks or not, because now we want to know how many of them could survive, how many of them could possibly die in 6 weeks, exactly at 6 weeks. So this is gone because we don't have information, so we exclude those. So let's summarize. Okay, so this is easy to understand, right? The original set or the previous set minus those who die at the previous level, and then we include those who cannot be studied previously, and then we minus those we no longer have information. Okay, so that is the quick summary. Now let's use data to analyze. Okay, here we actually have another method of calculating. So 10.8. So what we did in 10.8 is just one possible method to calculate the risk set. So now let's think of a different way of solving this problem, because eventually what we want to know is the number of patients who are exposed to the possibility of death at YJ. Possibility, exposed. Those are the two keys, right? So they must survive the previous level, YJ -1, and then we should have enough information to conclude whether this particular patient is exposed to the risk or not. So we can think of a different idea of solving this. 10.9 is an alternative method. So now let's take a look at 10.9 to see whether that makes sense. So we do not talk about the previous level of risk set. We directly start with everybody who is exposed, okay, within this level, within, not at. So right now we want to know anyone who not only received the surgery after, but also before, but must be less than this level. So what we do is, so anybody within this time will be considered. So anyone received the surgery after this time will be considered. Of course, will be between 0 and for this part will be between 0 and 12, and for this part will be from let's say negative yj to 0. Okay, anyone who at this level cannot be included because they obviously are not exposed to dying in YJ weeks, right? Because they already lived more than that. So it should be here again. This is a round bracket, means we cannot include exactly that point, right? That point, the exact point means that patient will live at least YJ weeks. So it's beyond our current level. Okay, that is everybody. Now let's do the minus and we cannot include anybody, right? Because this is the biggest set we have. We have to minus those who died and those who are right censored. So here the argument is we begin with the maximum possible. Okay, everybody who might die within are included, and then we exclude those who already died before this level and who are right censored before this level. Then it will be those exactly at, right? Then will be those who are exposed to the risk of dying at YJ. Okay. Again, now let's use example to better illustrate those two methods. The example actually comes from the previous case. So it actually comes from this table. So data comes from this table. Okay, we have 10 patients. So now let's do the analysis. Okay, so here are the results we need to derive. The first 4 columns are easy, right? So those refers to the first 5 levels, right? 2 is the minimum survival time, right? That refers to patient number 10. Patient number 10 survived only 2 weeks, okay? And then goes to patient number 4 who survived the 6 weeks, and then 7, 8, 9, etc. And then it will be those who live more than that. Okay, those are easy, right? So now what we are trying to do is we are trying to calculate RJ. Okay, now let's start with 6, not 6. Start with 2. Okay, at the beginning, we need to know who are exposed to the possibility of dying in 2 weeks. Okay, so we want to know that. Then there are 10 patients. We can label them from 1 to 10, right? So which is the GOR? So here. So this might be a better information. So let me first erase this. So remember the first is 2, so Y1 is 2. So who are exposed? 1 is not, right? Because patient 1 received the surgery 2 weeks ahead. So he at least survived the 2 weeks. So he's out. Patient number 2 obviously out, right? He received the surgery 4 weeks ahead. So by the start of our study, he already lived 4 weeks. Okay, patient number 3 is possible. Number 4 possible. Number 5 possible. Number 6 possible. Okay, 7 excluded. Again, 2 weeks ahead, 6 weeks ahead, possible. So we have 6 members, right? So in here we have 6, correct? Actually, we know who are exposed. 3, 4, 5, 6, 9, 10. Those are the patients who are exposed to the risk of dying at 2, meaning those are the patients who received surgeries after time 0, right? Of course, as long as the surgery was done, they are exposed. They are exposed to the possibility, right? Possibility, because we don't know yet, right? As long as their surgery was finished, they could die at week 2, right? Okay, here week 2 is a relative concept. Would be 2 weeks after their surgery. So that's possible, right? So for all those patients who received the surgeries after time 0, they are exposed to the possibility of dying, at 2 weeks. So that's why we have six patients at the first level, okay? And then we move on. We need to know who's in, who's out. So we need to exclude who passed away. Patient number 10 died at week 2, okay, 2 weeks later. So we need to exclude patient number 10. And then we also need to exclude those who are right-censored, right? So if someone is, because the next level is 6. So for right-censored, we have to exclude. So let's go back to the information to see who should be excluded. Let me erase this. So the first one is 2. The next one is 6. So obviously we have to take out this guy, right? Because they survive either 4 or 5 weeks, but we don't know whether they could survive for 6 weeks. So we need to take out number 6 and number 9. So take out number 6 and then number 9. Okay, we might need to add somebody. So let's say who we need to add back. We need to add those previously are not included. Previously are not included are 1, 2, and 7, 8. Now let's take a look. 6. So we have to bring him back because he is now exposed. At the beginning, we know he survived 2 weeks. So there is chance that he could die at 6 weeks. So that would be week 4 after the beginning, right? So it's possible. This guy is also possible. This guy is also possible, but not 8. Right? Patient number 8 already survived the 6 weeks. So there's no way he could die in 6 weeks. So we need to add back 1, 2, 7. So what do we have? So we are going to have 1, 2, 3, 4, 5, 6 is out, 6, 9, 10 are out. And we have 7. So if you count, we still have 6 patients, right? So that's why the next one still 6, right? It's the same number, okay? Move further. Now let's discuss the next one. We know there's 1 patient died within 6 weeks. That's number 4. Patient number 4 survived exactly 6 weeks. So we need to exclude that. And then we need to exclude anybody who right-censored. Well, it's between 6 and 7. there's no number. If you go back, right, between 6, 7, no number, right? So we have to be greater than or equal to 6, less than 7, right? This guy is equal to 7. So there's nobody to exclude from that sense. Let's say whether we need to take anyone back or not. So for the next one, we need to see. Oh, that's I did a mistake here. So it's the person number patient number 3 who died week 7. So number 7. So here is number 7, not. So the next one would be to add some. Okay, the second level. So I'm getting a little confused. So here it's I think that is right. So the first level is 2. The second level we are dealing with is 6. Okay. We need to see who we will need to add back to our study. That would be number 8. Number 8 will need to be included back, because if you go back here, what is number 8? Number 8 now is exposed, right? He's not exposed to 6, but he's exposed to 7. So we will need to add it back. So now we have 1, 2, 3, 4 is out, 5, 7, 8. So that's why we still have one member down here, right? So we still have 6. So it's interesting, right? For the first 3 we success, all of them are 6, and then the good thing is we will not to deal with add back, because once we add 8, all of them are now in the study, right? So we know later on the number will go down because there's no way we add anybody back. So for the next one, it's 7. So we need to minus the guy who died at 7. That is patient number 7. It's number 3. Okay, and then we also need to take care the right censoring. This guy will be taken out. That's number 5. So we will have 1, 2, 8. So that's why 1, 2, 3. Oh, we have 7 as well. 1, 2, 7, 8. So that's why we have 4. The last we deal with is 9. Then we see, go back to see anyone die. Okay, so number 1 died 9 weeks. So we will take out patient number 1. And when we look at the right censoring, both remaining numbers are bigger, so we cannot take any of it. So finally, we remove patient number 1. So we have 2, 7, 8. Okay, so that would be everything for this study. Okay, you can also do the using the other method, that is to at the beginning to see what are included, and then we minus what cannot be considered. So what it means is the other method is 10.9. Okay, obviously the starting point is the same. So the starting point is the same. But then after that, things could be different, because the next level is 6, right? So we know it would be 1, 2, 3, 4, 5, 6, 7, 9, 10. Okay, those are possibly exposed, right? Okay, those are possibly exposed. And then we need to minus those who died. The first person died at 2 is 10. And then we need to exclude right-censored before 6. So those two guys, 4 and 5, those are right-censored. That's number 6 and number 9. So number 6 and number 9. So we need to cross those two out, so we will get the same number, and then you do the same thing, right? So those two methods will give you the same result. There is pretty much no mathematics. It's just when you do this, you have to be very careful, right? You have to be extremely careful dealing with each subtraction and summation, right? You need to take out, in the first method, you need to take out who died and take out the right censored, and then you need to add back who had surgeries right within this level, okay, which are previously excluded. So it's about doing things in a careful way. Before we have all the observations in the individual level. Sometimes if your data set is too big, consider each observation may not be a good idea. In that case, it may be convenient to group up observations into some sub-intervals, so that the number of intervals, is relatively limited. You don't need to deal with all the observations, because if you have a huge data set and if the observations are quite distinct, let's say you have 1 million observation and 90% of them are different values, then you will have a huge list, right? And if you want to do it one by one, it's going to take a long time. But you might need to group them if they are relatively close, right? So you can group them if they are relatively close. Here we have k different levels. So here we have k sub-intervals. We group them together, and obviously those will be anybody who are in this interval. So we count for each interval, and then we have k of them. When you sum up, obviously they should be equal to the total number, small n, right? We try to do something similar. So the first risk set, it's simply n. That's obvious. Okay. Then we deal with the case of the next one. Well, it will be n minus n1. But in general, things could be different, right? Because here this is just for the complete case. For incomplete, you need to take into account left truncation and the right censoring. We need to possibly add back the left truncation, and then we need to minus those who pass away and who are excluded due to right censoring. So what we have would be those. So we need to add this back, but we need to minus those who die. This is not that. This is right censoring, and also those who passed away, right? So we need to do 2 minuses and 1 plus. Okay. Everything else is actually the same. The basic idea is the same, except right now it's not y, it's c. So before we do all the yj's, now we have cj's. Okay. We plus those who cannot be considered previously, because those are greater than cj minus 1. So obviously they will not be included in the previous interval, but now they are included in the current interval from cj minus 1 to cj, right? Okay, those we need to add. So it's a plus sign, and we need to take those who left or who died, right? So those are in this interval. So it's minus sign, and also we have some observations who that are right censored. they are right censored, you also need to take them out. So it's also minus. So, but the basic idea is the same, right, to the previous one. Okay, so it will be the previous level, okay, minus those who die, plus you add back those who cannot be considered before, and then minus the right censoring part. Okay, an alternative method is you consider everybody who are possibly exposed to CJ, okay, less than CJ, and then you need to minus the accumulated death. This is accumulated death. This is accumulated right censoring, and then you get exactly this level, right? So this is what you do is for everyone. So it's from 0 to CJ. This is given by this, right? So here you need to exclude those who die between this level and those who are right censored between this level, then will give you exactly from CJ minus 1 to CJ, right? So that is the second, second idea or second formulation for the formula. We do have some quick example down here. So we have one example. This is the data from, I think it's the same data, table 10.6. So it's the same one. Probably not. It's previously what we have is 10.5. So we may need the textbook to get everything. But nevertheless, once you figure out this, the last column is easy because you can simply apply the formula, right? So it's for instance, this is this minus this minus this. Okay, of course it's 13. The reason why you have 20 is because the previous level is 13. I need to plus those are new, and minus the, well, there's no death. Previously there's no death, right? And also previously there's no right censoring, so I get 20. So that's how I get 20, right? So once you have this, well, applying the formula will easily lead to the last column, right? So for instance, 16 will be your previous level is 20, and let's say, whether you get any new member, here you get 0 because you do not have anybody in, but you do have death 4, but you don't have right censoring, so you get 16. So it's 16 down here. So I'm sure you will be able to finish this table. So let me conclude and finish this chapter down here. I think in the next video I will get some exercise from our textbook and show those in the next video.